Welcome back. If VMware networking terminology sometimes feels confusing, you're in the right place. Today, we'll make VST, VGT, and EST simple by understanding one thing: who actually tags the VLAN? You may hear terms like EST, VST, and VGT, and initially they can sound like completely different technologies, but the concept is actually very simple. When a VM sends network traffic, that traffic travels through the virtual networking layer of ESXi and eventually reaches the physical switch. The important question is, who is responsible for identifying or adding the VLAN tag? Is it the physical switch? Is it ESXi? Or is it the virtual machine itself? That's exactly what EST, VST, and VGT are helping us understand. So in this video, we'll focus on one simple idea: where does VLAN tagging happen? Before we go deeper, let's first understand the full forms. EST means external switch tagging, VST means virtual switch tagging, and VGT means virtual guest tagging. The easiest way to remember them is to look at where the responsibility sits. With EST, the responsibility is external to ESXi, so the physical switch handles the VLAN. With VST, the virtual switch inside ESXi handles the VLAN tagging. And with VGT, the guest operating system or virtual machine handles the VLAN tagging. So remember this simple progression: switch, ESXi, VM. As we move from EST to VST to VGT, VLAN responsibility moves closer to the virtual machine. Let's start with EST, or external switch tagging. In this model, the physical switch is responsible for the VLAN assignment. The VM sends a normal, untagged Ethernet frame. ESXi simply forwards that traffic toward the physical network. The physical switch then determines which VLAN the traffic belongs to based on its configuration. So the important thing here is that ESXi isn't adding the VLAN tag. Think about it this way: ESXi doesn't need to understand the VLAN assignment. The physical switch does. That's why we call it external switch tagging. The VLAN responsibility is external to the ESXi virtual switch. Now let's move one step inside ESXi. VST stands for virtual switch tagging. Here, the VLAN ID is configured on the VMware port group. For example, suppose I create a port group called Production and assign it VLAN 100. The VM normally sends its traffic without a VLAN tag. ESXi receives that traffic through the port group and applies VLAN 100 to the outgoing frame. The physical switch then receives VLAN tagged traffic. So the key difference from EST is very simple. In EST, the physical switch handles the VLAN. In VST, ESXi handles the VLAN assignment. This is the model you'll commonly encounter when you configure a normal VLAN ID on a VMware port group. Now we move the responsibility even closer to the VM. VGT means virtual guest tagging. In VGT, the guest operating system is responsible for creating the VLAN tagged traffic. This becomes useful when a single VM needs to communicate with multiple VLANs. For example, one VM could generate traffic for VLAN 10, VLAN 20, and VLAN 30. The VM adds the appropriate VLAN tag to each frame. ESXi then passes that tagged traffic toward the physical network. On a standard vSphere switch, VLAN ID 4095 is associated with this trunking or VGT behavior. The important thing to remember is, ESXi is no longer deciding which VLAN each frame belongs to. The guest is doing that. So VGT effectively gives the VM a VLAN trunk-like connection. Now let's connect the theory to something you'll actually see in vCenter: the VLAN ID configured on a port group. There are 3 values you should remember for interviews. First, VLAN 0, or no VLAN tagging. In this case, VMware doesn't add a VLAN tag, and the physical network handles the VLAN assignment. This aligns with the EST concept. Next, VLANs 1 through 4049. If I configure a port group with VLAN 100, for example, ESXi uses that VLAN ID for the traffic. This represents the normal VST model. And finally, VLAN 4095. On a standard vSphere switch, 4095 is used to allow VLAN-tagged traffic from the guest to pass through ESXi, which is associated with VGT. So an easy memory rule is 0, switch handles it. 1 to 4094, ESXi handles it. 4095, guest tagging or trunking. One important interview detail: don't describe 4095 as a normal VLAN. On a distributed switch, VLAN trunking is configured using the VLAN trunking option and the required VLAN range rather than simply treating 4095 as a normal VLAN. Now let's bring everything together. If an interviewer asks you, what is the difference between EST, VST, and VGT, don't start with complicated definitions. Start with the most important concept. Where is VLAN tagging performed? EST means the physical switch handles it. VST means ESXi or the virtual switch handles it. And VGT means the guest operating system or VM handles it. You can remember it with just 3 lines. EST, switch tags. VST, ESXi tags. VGT, VM tags. And if you remember only one thing from this video, remember this. Don't memorize the acronyms. Remember who controls the VLAN tag. Once you understand that, EST, VST, VGT, VLAN 0, normal VLAN IDs, and VLAN 4095 all start making much more sense. That's the simplest way to understand VMware VLAN tagging. If you're preparing for a VMware interview, don't just memorize EST, VST, and VGT. Understand where the tagging happens and how the traffic moves from the VM to ESXi and finally to the physical switch. That's the concept interviewers are really testing.